Today we get to talk about really defining what a limit is and also learn some of our first really important notation. Limit notation is going to be a big deal. You have to follow the rules for limit notation and write everything the correct way. But before we get there, I would like you to think about how, without your graphing calculator, how would you sketch a graph of this function f of x here? We have x cubed minus 1 in the numerator, x minus 1 in the denominator. How would you think about graphing that? Hopefully, right off the bat, you notice that something weird happens when x is equal to 1. There's some sort of flaw in the graph, I guess you could say, a discontinuity of some sort. That's just a weird spot. Some of you might just create a table of values and plot points. Some of you will do any number of things. I can't really predict what you will do. But, you know, if we create our typical table, maybe we choose some negatives. We can't choose 1. There's something weird that goes on there. Maybe we do a 2. We can plug all of these in and we can get certain points that are going on. I don't know if anybody thought maybe we should factor that. And then you get the x minus 1s to cancel out. Now we just have this sort of parabola looking thing that has a vertex and some sort of thing going on there. Somebody may have tried to do that. But however you get that graph is valid. I want to know specifically, how do we know what's going on at x equals 1? Because we got it to factor and cancel here, we do know that there's some sort of open hole. But maybe we just end up making a table very, very, very close to 1. We don't know where that hole goes. You know, do we put it up at 7 or do we put it at 2? If we look at the table where we're getting closer and closer to 1, so our discontinuity value was at 1, and notice our values here are just getting very, very close to 1 from both directions. Okay, these numbers are approaching from the left. As we go from 0.75 to 0.9 to 0.99, we're getting closer to 1 and we're getting there from the left. On the other side, as we count down closer to 1, we say we're getting closer to 1 from the right. Okay, that helps us see these two numbers here are getting very, very close to 3. So if I had to guess what goes at x equals 1, there would be a hole, and the coordinates of that hole would be 1, 3, just based on kind of my little exploration there. So in fact, this is what the graph looks like. There is a little hole right there. It is at 1, 3, just as we suspected. Okay, now how does that tie into limits? Well, from our graph, we said, and our table, we said that these values were getting closer to 3, as were the values on the left. A limit, as we discussed previous in class, is just the value of a function, or that a function is getting close to. Okay, so not necessarily will the function equal the limit. Sometimes it does, but it doesn't have to. Okay, so very informally, the formal definition of a limit is not something we need to know. It uses epsilons and deltas and is a little bit scary. The informal definition here is something that you kind of just need to understand. Okay, it says as we have a function f becoming arbitrarily close, that just means super duper close, to some single number, L. In that last thing, it was 3. As x approaches c, that was 1 from either side. We say the limit of f of x as x approaches c is L. So here's your notation. Limit is abbreviated LIM, and it's of the function f of x as x approaches c is little like subscript here underneath of the limit. We're going to say x approaches c and then equals L. So that's your limit notation. Okay, this notation is super important. You absolutely need to know what this notation is. Okay, and how you read it is the limit of f of x as x approaches c is L. Okay, super important that we all say the same things and we all write the same things. Okay, so limit notation is going to be really big in this first part of chapter 1 for sure. Okay, I've warned you. Here's another warning. The notation in AP Calc, especially AP Calc, is super duper important. Okay, if you use incorrect notation, even if you get the right answer, the notation is part of that, so you don't earn full credit with incorrect notation. Okay, don't be lazy. You have to write the correct notation every single time. Okay, no laziness, no shortcuts. I write it how you need to write it, so take very good note of that. All right, so this would be a good time for you to pause the video and write the limit of f of x as x approaches -3 is 9 in proper limit notation. And while you're at it, fill out the second one as well while you pause the video. All right, let's talk about this and see if you were right. So the limit, we have f of x approaches -3, so we're going to have x approaches -3 is 9, so that means equals 9. Is that what you wrote? Great. How about the second one? Limit of, now they gave us a specific function. Okay, so we're going to write in x squared plus 4. And the parentheses are important because we want that whole function, not just x squared. And then it says x approaches -2, and that thing is going to be 8. Okay, I hope you got those two right. If you didn't, hopefully you see what you did wrong. All right, if we read these, this first one here on the left, how would you read that? The limit of f of x as x approaches -3 is 8. Something like that. The other one, the limit of x squared minus 3x plus 7 as x approaches infinity equals infinity, or is infinity. Okay, we don't always have to have numbers down there. That's fun. Another super fun thing about limits is we can have limits that are only one-sided. Okay, that means we're going to either approach only from the right-hand side, so coming towards our target value from the right, or from the left. And the notation is slightly different. So limit of f of x still, but now here we have x approaches 3, but notice we have this little plus sign, kind of almost looking like an exponent. Okay, that's what tells us we're going from the right. All right, if we want a left-handed limit, because now we have this negative sign kind of up in the exponent, that means from the left. I always remember it because the negative numbers are to the left and positive numbers tend to be towards the right. So when those positives and negatives are kind of like exponents behind, they really just mean from the left and from the right. Okay, now the really fun, this is my favorite stuff right here. If I just give you, let's say, these three properties right here, and I ask you to sketch a graph, any graph that has these three properties, you can do that any number of ways. Okay, I left blanks for 3 different ways, but there are probably more ways to write that or to sketch these than those. So we're just going to talk about sketches. Nothing has to be on graph paper or anything like that, just quick sketches. Okay, this means, this first one up here, means as we get really close to 3 on the x-axis, so it's kind of a target value there, our function has to go up to 4. So 1, 2, 3, 4. We have some sort of, from the right side, our function has to come up to there. Okay, I don't know if that's a closed-in circle, but it could look like that. Then it says from, in this second part here, it says the limit of our function as x goes to 3 from the left is -2. So as I get closer to -2, or to 3 from the left, I have to get close to -2. I put my 3 in the wrong spot. Okay, so maybe there's another open circle there. Okay, and maybe this part of the graph just is a straight line. I don't know what it looks like. Okay, so we have our 2 pieces right there taken care of. And now it says our third thing. It says f of 3 equals 0. That's just an ordered pair. That says when x is 3, y is 0. So now I have to put a dot at 3. Okay, so there were these 3 stated properties, as well as the implied one here that you have to have a function. So this, our graph would have to pass the vertical line test as well. Okay, there are different ways you could do this. Certain pieces have to be the same. Like all of this stuff right in this area pretty much has to be the same. What your graph does, you know, where I drew a straight line off to the left and a slightly curved thing off to the right, those things could be different. And that's how you can get different things. But your limits right there and that I circled in pink, those pretty much have to be very similar to that. So I would like you to wrap up your notes for this section. I would like you to sketch 2 different options of a function that has these properties, and we'll talk about those in class when you get there.